Now, continuing in section 4.1, let's look at another study, sleep versus caffeine. The question behind this study is there a difference in average word recall between sleep and caffeine? Students were given words to memorize, then randomly assigned to take either a 90-minute nap or a caffeine pill. 2.5 hours later, they were tested on their recall ability. So you can see that, going back to chapter 1, this is an example of a randomized experiment. Students are randomly divided into two groups. Each group gets a different treatment. So one gets the 90-minute nap, the other one gets the caffeine pill. And at the end, they are all tested on their recall ability. So there is an explanatory variable, whether the student got sleep, the 90-minute nap, or caffeine. And they were all tested on their recall ability, and the response variable would be the number of words recalled. So here we're going to set up null and alternative hypotheses, but we're concerned with a population mean now, the mean number of words recalled. And the population is divided up into two groups. One group is the sleep group, the other one is the caffeine group. So what we have to do for something like this is, in addition to using the Greek letter mu, we have to use subscripts for the two groups. So mu sub s for the mean number of words recalled by the sleep group, and mu sub c for the mean number of words recalled by the caffeine group. Now, when we're using mu, it's not just the students who participated in this experiment. It would mean the mean number of words recalled by everybody in the population who would have taken a 90-minute nap. Like mu sub s would be the mean number of words among the whole population of those who took a 90-minute nap and then tried to recall words. Likewise, mu sub c would be the mean number of words recalled by everybody in the population who first took a caffeine pill and then had to recall words. So remember, the null hypothesis is a statement that there is no difference or no effect. So in this case, it would be stating that there is no difference in terms of word recall between sleep and caffeine. So the mean number of words memorized would be the same for both. Mu sub s equals mu sub c. Now, the way the question was worded, it did not suggest that one was better than the other. It just asked, is there a difference? So here, for the alternative, we would make it mu sub s not equal to mu sub c. So that includes the possibility that mu sub s is greater than mu sub c. Also includes the possibility that mu sub s is less than mu sub c. Now, we could alternatively write the null and alternative hypothesis like this. The null could be written as mu s minus mu c equals 0. And the alternative could be written as mu sub s minus mu sub c not equal to 0. So this second set of hypotheses is mathematically equivalent to the first set of hypotheses. And which one you use is just due to personal preference. So you've seen the ESP example, and now you've seen this sleep versus caffeine example. Let's see if we can come up with the null and alternative hypotheses for the following situations. So a study first asking, does the proportion of people who support gun control differ between males and females? So first we're talking about an unknown population proportion, P, but the population is divided into two groups, males and females. So just like with the sleep versus caffeine study, here we have to use P with subscripts. P sub M for the proportion of males and P sub F for the proportion of females. Now, for the null, it would be stating that there's no difference between males and females. So we would expect to see PF equal to PM. And this question does not suggest that, say, males are more likely to support gun control than females or vice versa. So for the alternative, again, we would expect to see not equal to. So null PF equals PM, the alternative PF not equal to PM. The second question is the average hours of sleep per night for college students less than 7? So you see the word average. When we see that, we think of mean. And remember, the null and alternative hypotheses refer to the population mean, mu. Here we only have one group, so we just need to use mu. Now, the question is the average hours of sleep less than 7? Well, we would use that less than in the alternative hypothesis. So the alternative would be mu is less than 7. What would we use for the null hypothesis? We would state that mu is equal to 7. Now, we've seen that the first step in setting up a statistical test is to set up null and alternative hypotheses. And the idea is that then we would gather data and use the data to determine whether we have evidence to reject the null hypothesis in favor of the alternative. And the question we're always asking is are the results extreme enough to reject the null in favor of the alternative? So when the results are as extreme, when we see results as extreme as the observed sample statistic are unlikely to occur by random chance alone, assuming the null hypothesis is true, we say that the sample results are statistically significant. So for example, if you guessed, back in the ESP example, if you guessed correctly 8 times out of 10, that's rather unlikely to occur, assuming that you have no ESP. So that might lead to concluding that the results are statistically significant. So in general, if your sample is statistically significant, it means you have convincing evidence against the null hypothesis in favor of the alternative hypothesis. On the other hand, if your sample is not statistically significant, what you would say is your test is inconclusive. You would never say that you accept the null hypothesis. We just absolutely never say that. We either say that our test is inconclusive or not statistically significant, or we say it is statistically significant, which means that we have evidence against the null in favor of the alternative. So you probably have gathered by now that this is not easy. So it's a difficult concept. Difficult at first, I would say. But once you see a few examples, it becomes much easier. And it's one of the most fundamental concepts of the course. And we're going to return to this almost every class for the rest of the semester, so it will get easier. And it's worth thinking deeply about. So back in the ESP example, we see here the null and alternative hypotheses. Now let's suppose that we had a couple people participating where one was trying to telepathically communicate to the other, and the other one would guess, and they did this 10 or 20 or whatever times. And if after all was said and done, the results were stated to be statistically significant, it would mean that the sample proportion of correct guesses is higher than is likely just by random chance, assuming that ESP does not exist and P equals 1/5. So, for instance, as I've mentioned before, if you guess correctly 8 times out of 10, that's not a likely result if in reality you don't have ESP and your true chance of guessing correctly is 1/5. So it would mean also that we have evidence that the true proportion of correct guesses really is higher than 1/5, and thus we have evidence of ESP. On the other hand, what if the results are not statistically significant? It would mean that the sample proportion of correct guesses could easily happen just by random chance, assuming that ESP does not exist and P equals 1/5. So as I may have mentioned before, what if you guess correctly 4 times out of 10? I know that's greater than 1/5, but that could have happened by chance. And it would mean that we do not have enough evidence to conclude that in reality, the long run proportion of correct guesses P is greater than 1/5, or that ESP exists. So to summarize section 4.1, statistical tests use data from a sample to assess a claim about a population. They are usually formalized with competing hypotheses. The null hypothesis, which corresponds to a statement of no effect or no difference, and the alternative hypothesis, which is a statement concerning what we seek evidence for. If the data are statistically significant, we have convincing evidence against the null hypothesis and in favor of the alternative. So we'll stop there. Next time we'll go on to section 4.2.